In this tutorial, we will be discussing specific heat and heat capacity. Heat capacity is the quantity of heat, usually in joules, required to change the temperature of a given amount of a substance by 1 degree Celsius, which incidentally is also 1 degree Kelvin. When the amount of a substance is expressed in grams, the heat capacity is called the specific heat capacity, or just simply the specific heat, and has units of joules per gram per degree Celsius. It could also say joules per gram Kelvin, because remember, as Celsius changes, so does Kelvin. Here's a list of a few specific heats. Notice that the highest of them is water. Water has a cooling effect on our environment, because of the fact it takes a lot of energy to be absorbed to change it just 1 degree. If there was no water, the earth would be extremely hot because there would be nothing to absorb the heat from the sun. So here's the equation that relates these quantities. Q is the amount of heat in joules, M is for mass in grams, C is the specific heat, and notice this triangle here. That is representative of the Greek letter delta, and it's an abbreviation used in science to mean the change in. So triangle T says delta T is how you say it, and it means the change in temperature, and that's always the final temperature minus the initial temperature, how the temperature changes. We can use this equation to do some practice problems. If you hold gallium in your hand, it melts from your body heat. How much heat must 2.5 grams of gallium absorb from your hand to raise it from 25 degrees Celsius to 29.9 degrees Celsius? So here is our mass in grams. We subtract these two to find the change in temperature. So this is our delta T, and that's going to be 29.9 minus 25.0, which is equal to 4.9. The specific heat capacity is 0.372 joules per gram degree Celsius. So we're going to take the mass, 2.5, times the specific heat, times the change in temperature. Multiply that all together. Notice that the grams cancel and the degrees Celsius cancel, and we're left over with joules. And it comes out to be 4.6 joules. Two significant figures because we have 2 here and we also have 2 here. How many joules are required to raise the temperature of 1.074 grams of iron, so this is our mass, from 25.1 degrees Celsius to 100. This will become our delta T when we take 100.0 minus 25.1. That comes out to be 74.9. And then we have the specific heat of iron right here. So 1.074 grams times the specific heat times the change in temperature. Once again, temperature cancels, grams cancel, multiply it out, and we have 36.1 joules. We have 3 significant figures because we have 3 right there. And our final one is a little bit trickier. A 0.25 kilogram bar of aluminum at 23.8 degrees Celsius has 15.5 kilojoules of heat added. What is the final temperature of the aluminum? And we have the specific heat. Tricky for a couple reasons. One, we're given kilograms and kilojoules, so we have to convert that out. Plus, it's looking for the final temperature, which means we'll have to have 2 steps, because to find the final temperature, we need to find the change in temperature, and then plug it into this equation. So let's calculate this first. 0.250 kilograms. There's 1,000 grams in 1 kilogram. So that becomes 250 grams. Then we have 15.5 kilojoules. There's 1 kilojoule in 1,000 joules. So that becomes 15,500 joules. Now we can plug this into the equation. We're looking for delta T. That comes out to be 68.6 for a delta T. Now we can plug this into the equation. We're looking for the final temperature. Our initial temperature is 23.8. Add that across and we get 92.5 degrees Celsius. And that's how you do specific heat.